Last part, I would like to talk a little bit about the power calculations. And power calculations, they can be done in two ways. We can calculate per phase power, and we then multiply for the total power. We will multiply them by 3 and we will get the 3 phase power. So what is happening in this case? For example, we have this load, or even we have a delta load. So this is A, this is B, and this is C. A, B, and C. So what will happen is, what is phase voltage here? Okay, we consider this to be the 3 lines. So this VAN is actually V phase, and the current through this is I phase equals to IAN, and impedance of this is Z phase. So no matter if you have the line voltages here, or even if you know at the source size the phase voltage, you can calculate the line voltage, and we have seen how you can solve and calculate I phase. So in this case, you can calculate P single phase as V phase I phase cos of theta. So V phase now is VAN IAN cos of theta. So, but for example, here this was 100 volts 0 degrees, and we have IAN. So the value of this is 100 volts 0 degrees, and for the current we say we have value is 5 ampere minus 30 degrees, and the theta, the phase difference between this is 30 degrees. So in this formula we will not be writing 100 volt 0 degree into 5 ampere minus 30 degree into cos 30 degree. No, here it is not the phasor, here only the magnitude is coming. So 100 into 5 into cos of this, and this will actually give you the value. Similarly, if you look at this case for a delta load, here V phase equals to VAB. There is a difference between Y load and delta load. Here we can calculate I phase as you have seen before. We have ZAB. So again we can calculate P phase equals to VAB, IAB, and cos of theta, and only the magnitudes of this will come here and the angle between them will come here. This will give you the per phase power, and to calculate the total power you have to multiply this by. Similarly here for total power you have to multiply by single phase power. So this is how you can calculate by the first method, that is by using the per phase power, and then for a balanced load we can use this method and solve the values. The second case is related to by using a unified formula, and let me make some space. Let's look at this, and this you can calculate like this. Now let's again look at our loads. For example, this is our Y load. This is A, B, and C, and from here we can see these are the line. Now if we know the line voltage VAB, and if we know the line current IA, then we can calculate, we don't have to calculate per power. In one go, we can calculate the total power, three-phase power of the system by under root 3 line voltage VAB, line current IA, cos theta phi. But remember this thing, this is a point where a lot of students make mistake, that this theta phi is not the angle between VAB and IA. This theta phi is actually the angle between V phase and I phase. So you must be very careful when you are doing calculating this one. So you have to know the angle of the load. You have to know the angle of the load and the angle between the phase voltage and the phase current. Then you will be able to use this formula. Similarly, if we have a delta load, A, this is B, this is C, and what we have here is, in this scenario, the total power again can be calculated by under root 3. We have the voltage VAB, which is line voltage and phase voltage are same. Then we have the current IAB, this is the phase current for delta load. And then again cos theta phi. This is again the angle between the phase voltage. Oh, sorry. Here I have done a mistake. I will again write this formula. P total is under root 3 VAB. This is also the line voltage, and IA line current into cos theta phi. Okay. Here again, this is not the angle between line voltage and line current, but this is the angle between phase voltage and phase current. This is the angle between VAB and IAB. Similarly, you will again follow the rules as I have told you before. So this is for PT. For QT, we know the sign changes. And for the power S, this is under root 3 VAB IA. Same goes for here, for QT also, and for ST. And when we have used per phase equivalent, the same formula also exists for QT, V phase, I phase, but sine of theta. And for this was for Y case, and similarly for this delta case also. QT, we have the same VAB, IAB, sine of theta. Okay, thank you.